Hi, I'm Paul Bechwith with the University of Ottawa Laboratory for Paleoclimatology. I posted a video just yesterday called basically H-bombs can arrest or stop abrupt climate change. And I knew it would be controversial. I don't steer away from controversial videos. I'm not saying this is something that we should ever do. What I am saying is that we need to declare a global climate emergency. We're seeing exponential changes in all different features. We're just losing, as I speak, the largest ecosystem on the planet, the coral reefs in Australia, the Great Barrier Reef in Australia. We do know from the Cold War and weapons testing, we know about nuclear explosions and how they interact with the surface, and these, of course, were weapons for mass destruction, killing of people. If a comet or a meteor was coming at us, we might consider, we had enough warning, we might consider deploying one to divert the path of such a thing. We know, so I'm just asking the question, can H-bombs, in controlled fashion, how would that interact and affect abrupt climate change? Could it slow and stop abrupt climate change? So that's what this video is all about. So this is a paper from 2000, this is an article from 2009. Lots of scientific papers were done on this. It's Alan Roebuck and Owen Brian Toon. You can just Google it and find it. So let's have a look at what it's saying. Okay, so the first thing is that we do know quite a bit about what the effects are. During the Cold War, there were lots of tests with increasing yields of nuclear weapons, whether they were standard fission bombs or wrap hydrogen around, making it H-bombs, which are much more powerful. So how do they affect the atmosphere? Well, this is Mount Pinatubo going off in 1991. So it threw ash miles up into the air. Now, Mount St. Helens didn't change the climate because it was a powerful volcano, but it was mostly going horizontally. To change the climate, a volcano has to hurl ash and debris up into the stratosphere above the weather where it's not rained out, and then it will affect the climate for years. So Pinatubo cooled the climate for years. This shows 4 different particle layers that circumnavigated the planet after Mount Pinatubo. So let me bring up this. So what happened after Pinatubo? This is the global air temperature before and after. So the eruption was here, 1991, in the 1990-1991 time frame. It erupted, and the global temperature dropped. So it dropped. It's 0.3 above, 0.4 below. It dropped about 0.7 degrees over the next year, and it stayed low. It was down by 0.2 to 0.5 degrees C for a period of 1 to 3 years. And in that time period, the ash and debris in the stratosphere was pulled down by gravity, hits the troposphere, and then it's rained out very quickly. This is just one graph of it. This is there's all kinds of papers on Mount Pinatubo, both at the time, around the time it happened, and years later. There's still now even papers coming out of how long it takes, how the ash is distributed in the stratosphere around the planet, and how much cooling it would cause. Years ago, I did a blog on the anthropogenic Arctic volcano. Could we cool the Arctic by simulating a volcano, putting sulfur dioxide in the atmosphere? So there's all kinds of graphs here on the radiation, short wave, long wave, etc. Models of how much the temperature would drop, and the data shows about a 0.7 degree temperature, and the models accurately show that, and also the time frame over which there's cooling. So what happened if there's a nuclear exchange between India and Pakistan? There'd be an enormous human toll. 20 million people could die directly, but about 1 billion people worldwide would lack food and starve. So this obviously, this is a scenario that we don't want to happen. Let's have a look at the effects on the atmosphere. So this is about 100 warheads, 15 kilotons each. That would be a net yield of 1.5 megatons, which is minuscule compared to what one modern nuke carries. I mean, people need to realize nuclear winter and what it would do to the planet. You know, in the Cold War, you know, if, say, the US had a surprise attack on the Soviet Union and destroyed it with nukes before they could respond, then the entire planet would cool and there'd be famine and billions of people would die from mass starvation. You know, same if the Russians did the same thing. This basically ended the Cold War because neither side could accept. You know, there's no way you could defeat the enemy without taking out the whole planet. So this shows the ash spreading from 5 teragrams of smoke. May 15th, 5 days later, and I can show you what happens. This is 9 days after the exchange in India, Pakistan, and this is 50 days later. And you can see that about 10% of the sunlight on average, is being blocked. Only 90% is getting through. So what does this do? Well, it obviously causes a significant cooling of the planet. So this is the key graph, okay? So this nuclear conflict would lower the temperature 1.25 degrees, and after 10 years it would still be half a degree lower. Now, we're going through abrupt change. I mean, the temperature rises, and these curves, you know, I don't know about you, but I get tired of seeing these curves just heading up, you know, in sort of exponential fashion, abruptly, you know, spikes in the curves. You know, and it looks like, you know, this is really dire. Like, you know, sure, we can we need to do the three-legged bar stool solution. We need to slash fossil fuel emissions, leg 1. We need to remove CO2 from the atmosphere, leg 2. We need to apply solar radiation management methods to cool the planet so that, you know, and I always say cool the Arctic is the most important because the Arctic's warming like crazy. And if we start getting the emissions of CO2 and methane from the permafrost and ocean seafloor sediments in the Arctic, then we're basically going to rocket up. And I'm a bit concerned because in 2015, the CO2 levels rose 3.09 parts per million. And, so, you know, they rose the year before, not as much, in 2014. But supposedly, global human emissions have leveled off. And if they've leveled off and the CO2 is still going up in the atmosphere, then what's happening? I mean, more is coming from the oceans, etc. So, I'm not suggesting that this type of thing be done, because something like this being done would cause an enormous temperature decrease, and that would wreak havoc. It's the change of temperature that people, you know, don't, you know, respond very well to, or the biosphere or anything else. So right here, we're getting spikes up, and we're losing things like the coral reef. So what if we could, now we have lots of parameters to vary with H-bombs or smaller yield bombs. Like, for example, you know, the yield of the H-bomb can be varied, and also where do you let it off? If it's in the atmosphere, it won't affect the climate that much. It doesn't it doesn't send up too much into the upper atmosphere. If it's an underground test that doesn't break the ground, then it has no effect on the climate. But if it's shallowly buried and designed to loft a specific amount of rock and debris and earth, and, you know, if it was in the desert, it would just be sand. If it was under a salt flat, it would loft the salt particles up. If it was under a forest, it would incinerate the organic matter and send that up into the upper atmosphere. And these things can be, you know, it can be scaled up. You can start really small and scale it up. So maybe you try it a small one and then drop, you know, you take off that delta function going upwards and you flatten it out. You know, try a few more and you lower the curve. Try a few more. I mean, you tailor it. You don't try to do something crazy like this, but this is a technique that is essentially, you know, it's basically free. I mean, we have those bombs. I mean, there's a couple things, you know, going back to this plot here. Okay, we know the yield that would generate this. This would cool the entire planet. And what that would do is it would cool the oceans. and when the oceans are colder, they can absorb more CO2. So if we reach the situation where the Earth is putting out more greenhouse gases, then we cut our human emissions to zero, even start dropping them, and the Earth is still producing lots of CO2 and methane because we've left it too late and the Arctic's warmed like crazy. Something like this, which would cool the oceans, would then cause an increase in absorption of these gases and decrease these gases. I mean, it's all a matter of, we're in an extreme situation right now. We're in a global emergency, and I'm just trying to let people know what would happen. This is what would happen with nuclear winter. I'm trying to let people know these things. I'm just the messenger. Don't be naive and think that the military has not looked at this in Russia, in the USSR, in the USA. This stuff is all, this stuff was all studied intently during the Cold War, and it was determined that, an exchange, an uncontrolled exchange, would basically trash the food supply. But if you did small tweaks to this curve, all I'm doing is saying that, if we can't bend this curve over by doing all of the nice things like, slashing emissions and, maybe companies or, reforestation to remove CO2, maybe plankton, algae farms, stimulation in the ocean to remove CO2. If none of this stuff is working and we're getting total chaos in society, then it's nice to have some extra tools in the toolbox to basically try to stabilize the system and, knock this curve to flat and then lower it down. So these are just things that, can we do it? The physics is showing that yes, we can. Should we do it? That's a totally different question, which I don't want to go there. So if people are saying I'm advocating this, then that's not what I'm doing. I'm just showing how the climate system can respond to the lofting of aerosols up into the atmosphere from an H-bomb, for example. So I think I'll stop here, and thanks for watching.